So we are going to solve some questions on pulley, right? It's a part of uh, we are going to solve questions on you know that we call pulley, right? Pulley and pulley. It's a part of machine, right? This is we have machine pulley. So it is saying a, in a block, sorry, in a first question it is a single fixed pulley. Yeah, there is a single fixed pulley. Single fixed pulley we have, right? In single fixed pulley, what happens? There is a surface, right? And it is fixed. So this is the wall, and here it is. This is here. This is axle, right? Now, if we have a thread like this is here it is load, and this is single movable pulley, right? This is having load. Here we are putting effort. So there is a tension, there is a load, right? So, so load is equal to effort is equal to T, and effort arm is equal to load arm is equal to D, right? So mechanical advantage is equal to load upon effort, so it is T upon T is equal to 1, and velocity ratio is equal to effort arm upon load arm, that is D upon D, that is equal to 1. So this is single fixed pulley. Now we have a movable pulley. A movable pulley. We have movable pulley. in that what happens, there it is, you know, there it is. As given, DE is equal to DL. So velocity ratio is 1 in this case. And here also there is a movable pulley, you know. This is a movable pulley. Single movable pulley. Single movable pulley. There is a string and here is effort. So this is the effort. Tension is also on this side and load is here. Load is here, right? So you just see here key effort is equal to T. This is also T. This is also T. So effort is equal to T, but load is equal to 2T, right? So mechanical advantage, and next we have effort arm is equal to D and load arm is equal to D by 2 half. So mechanical advantage is equal to 2T upon T, cancel out 2. Mechanical advantage is 2. And velocity ratio is equal to D upon D by 2 will give you D and D cancel, 2 goes up, it becomes 2. Velocity ratio and mechanical advantage is 2 in a movable pulley, in a single movable pulley. Mechanical advantage is 2. So when mechanical advantage to compare the efforts, load, okay, this is effort and this is load, right? Load is of 50 kgf. 50 kgf. right? So effort is here is, and since mechanical advantage of one, so mechanical advantage is 1 for movable pulley. So mechanical advantage is 1 and load is 50 kgf. So mechanical advantage is equal to load upon effort, load upon effort. So 1 is equal to 50 kgf, 50 kgf upon effort. So effort is equal to 50 kgf, right? This is we have for this effort is of 50 kgf in single fixed pulley, and here load is 50 kgf. So mechanical advantage is equal to 2 is equal to load upon effort. So 2 is equal to 50 kgf upon effort. So effort is equal to 50 kgf upon 2 becomes 25 kgf. So half effort mechanical advantage is 2. Mechanical advantage is 2. So half 25 kgf required in single movable pulley as compared to fixed single pulley, right? Here is 25, it is here is 25 kgf, it is 50 kgf, so half less effort is required, right? This is the answer of the question we have. This is the answer of the question we have. And the next one is in a block and tackle system containing 3 pulleys and a load of 75 kgf raised with an effort of 50 kgf. Okay, in a block and tackle system consists of 3 pulleys. Okay, so question number 2. In block and tackle system, in block and tackle system, with with 3 pulleys, what happens? What happens? We put like this. This is, we have one, this is block and tackle system, right? And here is, and here is also a pulley, block and tackle system of 3 pulleys. So there is a one more pulley here. Okay, there is a load. There is a load, right? In block and tackle system, 3 pulleys, and there is a load, and it is given that load is of 75 kgf. This is of 75 kgf. load is of 75 kg, right? Now what we do, strings we take like this. This is a string. This is, here is effort, here is tension, here is tension, here is tension, and here is tension. In block and tackle system, an effort is of 25 kgf. 25 kgf. Right. So in block and tackle system, in block and tackle system, mechanical advantage is equal to load upon effort. So it becomes 75 kgf upon 25 kgf. It becomes 3. Mechanical advantage is 3. And velocity ratio is number of pulleys. Velocity ratio is number of pulleys. So velocity ratio is equal to n is equal to 3. So velocity ratio is equal to 3. Right. So mechanical advantage is 3, velocity ratio is 3, and it is asking for efficiency. So efficiency that is eta is equal to mechanical advantage upon velocity ratio, that is 3 upon 3 is equal to 1. So 1, and efficiency percentage is equal to 1 into 100%. It becomes 100%. This is, we have block and tackle system, right? And how to solve the question like this in block and tackle system. Now we have another question. Question number 3. Okay, question number. There are 5 pulleys. Okay, so this is question number 5. Question number 3 we have, there is a block and tackle system. Block and tackle system with 5 pulleys. Right. So here it is. This is the fixed surface. We have one is like this, another one is like this, third one is like this. Okay. Now if you right here, there is a hook. Another we have two more. This is and this is 5 pulleys block and tackle system, right? Okay. Now copy the diagram with drawing string around the pulleys. Mark the direction of load and effort. Okay. So this is like this. Okay. So again, if we take from here, this is like this, coming here, then it is going like this, coming here. In lower block, always pulleys are less than the upper block, right? Like this, like this. This is. So this we get the effort, right? Now, what happens? This is the tension. 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 And this is tension. So we have, one, two, 3, 4, 5 tensions. Okay. And here is, here is a load. Here is a load. Right? Here is a load. So this is load. Okay. Okay. This is the load. This is the ray diagram. direction of mark load and effort. Load is always downwards, effort is like that. So velocity ratio is equal to number of pulleys in block and tackle system. Right. So here N is equal to number of pulleys is equal to 5, and it is saying that if load is raised load raised load raised 2 meter, means load arm is equal to 2. Velocity ratio is 5. So velocity ratio is equal to effort arm upon load arm. Okay. Load is raised by 2 meter. Through what distance the effort moves? So we have to find here effort arm. So velocity ratio is 5 pulleys 5. So it is 5 is equal to effort arm is, we have to find, upon load arm is, load is raised 2 meter. So it is 2 meter. So therefore effort arm will be 10 meter. So effort move 10 meter. Effort move 10 meter. Right? This is the solution of the question. Load moves 2 meter to effort velocity ratio is equal to number of pulleys and effort arm upon load arm, dE upon dL. So dE is equal to 10 meter. So it is 5 times 2 becomes 10. So it's 10 meter. So load will be raised, but so effort will be effort moves 10 meter. Yeah. So this much is sufficient for this time for pulleys, which is a part of machine. So thank you.